So it's actually called iterated okay, iterated or repeated hmm, integrals. You can see my screen, right?
Can,
Yes,
doctor.
doctor.
Okay, good. Okay, so it's called iterated or repeated integrals. All right. So, oops. Okay, so for iterated and repeated, do you want my screen this way or do you want me to go portrait, landscape, or portrait? Both okay?
Landscape, doctor.
Landscape. Oh, landscape macam ni lah. Okay. 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 So when we're looking at iterated or repeated integrals, okay, what you can do is you're talking about double or even triple integrations. Okay. So there are very specific methods of doing it. Okay, but before we actually do it, I will explain to you the process exactly how we do it. So we can do step by step. Okay, so I always teach you step by step so that you just follow the step and you're not gonna go wrong. Okay. Okay, so let's say we have so for a specific function, for a specific function, x and y, for example. All right. The volume under the surface. So when you integrate a curve, you know what you get, right? You get area under the curve, right? You know, right? Do you?
Yes, doctor.
Okay. I just want to make sure you know so that this is I need to make sure you know the calculus 1 stuff before I teach you the calculus 2 stuff. Okay. So for any function, the value under the volume under the surface over a region R is given by this. Okay. All right. So in calculus 1, when you have a function, I don't know, let's say like that. Okay. When you integrate this function, let's say over two limits. Yeah. When you integrate, you have limits, right? Yeah. You have this limit. You have, let's say beta and alpha, the bigger and the smaller limits. Okay. So when you integrate something over two limits, what you're actually getting is you're getting area. Okay, under the curve. Okay, so this is calculus 1. Okay, now in calculus 2, what we're doing is because in calculus 1 we have two variables only. Okay, so it's 2D. In calculus, in calculus 1 we have two variables, so it's 2D. In calculus 2, we are looking at least 3 or 4 variables. So it becomes 3D. So this curve becomes a surface. So when you integrate under the surface, you actually get this volume. Okay? Okay, so in 2D, you integrate under a curve, you get area. Yeah, area. Yeah, area. In 3D, you integrate under the surface, you get a volume. Okay? Now, the process of doing it, okay, it's like that. Okay, so example, okay? So let's say, so let's say I have this this function. Okay, and I'm telling you the region is this and this. Okay, so I have this function. Yeah. Well, wait, that's not the function. This is the function. And this is the limit as defined by the region. Yeah. So on the right hand side is a function that you actually integrate. On the left hand side is the limits that is defined by the region. And for that region, you refer to this. So this gives you the actual limits. Yeah. Okay. So let me drink water. Okay, so with this question, okay, well, with this topic, the first step is always draw the region. Okay, the first step is always you draw the region. So when you draw the region, it looks like this. Okay. Okay, so the limits, the x-axis limit is from what to what? Yeah, limits. X-axis is from what to what?
0 to 1.
Correct. Very good. From 0 to 1. That is your x-axis limits. Okay. What about the y-axis limits? Someone else? Quick. Someone else in the class.
Negative 1 to 2.
Okay, good. Thank you. Okay. Negative 1 to 2. Okay, is your y. All right. So therefore, the region for your limit is this. Okay. Now this is very important. This is very important. Later on, you'll find drawing this, whether you know how to draw this or not, will dictate on whether you know what the limit is. Sometimes the limit is not this straightforward. You need to draw this to know what the limit is later. Okay, you will see. Okay. So we draw the region. So why did I ask you to draw this thing? There is a reason. Okay, you need this thing to actually tell you what the limits are. Okay, so now next step, you set up the integration. Okay, if you notice in the original question, I just told you R. I didn't give you the limits exactly. Okay, I just put R in there. You have to refer to the region. Yeah, R. So now you have to set up the integration by putting the actual limits in. Okay, so the way you do the limits is like that. Okay, so if you want okay, so if you want to differentiate against x first, okay, if you want to differentiate against x first, then yeah, the x, so that means I want to differentiate against x first. What that means is then my limits is the first set of limits has to be x limits. Okay, so to get the actual x limits number, you go back to your region, you go along the x-axis. You shoot a line from left to right along the x-axis. Yeah, that line, for that line, the first point that it touch is the first limit. So the red color line from left to right, what is the first? Is that correct? Dx. Yeah. What is the first x-axis value that is touching? That axis. X equals to what?
0.
Yeah, correct. 0. Yeah. And then so that red line, let me do it this way, but then it's clearer. Wait, let me do it this way. Okay. You pay attention. Now I'm drawing a red line. You see I'm drawing a red line. Boop. That red line hits a point there. That point is x equals to 0. Yeah. Then I continue. With a red line. Yeah, everyone pay attention. Boop. I hit another point. I hit another line there. What is that line? Yeah.
1.
All right, x equals to 1. Then I continue, then there's nothing else to hit. Okay? So the two lines that my red line hit is the limit. You see, one of them is 0, one of them is 1. Therefore, your limits is the first one and the second one. That's how you get your limit of integration. This is very important. Later on, you will rely on this a lot. Okay. Next, I'm going to use green color. Next, obviously, because we have x and y, that means we have to differentiate against y as well. Okay. So for y, same thing. You go bottom to up. So from bottom, I go up. I draw my green line. I go up. Boop. I hit something here. This is y equals to what?
-1.
Very good. And then I keep going. Boop. I hit another one. This is y equals to what?
2.
Very good. Thank you. This is your dy line. Okay. So you have to draw your dx and dy line to get your x and y limits. So as you can see, my line hits y equals to -1 first. And it ends at y equals 2. Those are your limits. Okay, So once you get the limits, do you know how to solve it? Well, just integrate normally. Okay. So if dx comes first, that means you integrate against x first. Okay. You integrate this one, you integrate the left hand side first, you integrate the right hand side second. Okay. Now in this case, I can also do, if I want to, I can also do this. dy first and then dx. Okay, I can flip it around, no problem. But later on, there will be some examples whereby you cannot do this. Okay, for this question you can. Later on, there are some examples where you cannot because of the region, this region. Okay, so this region, it will be very important. Okay, I keep saying that because it is very important. Okay, so never mind. So let's finish integrating this first. Okay, so integrate against x first. So how do you integrate? I can't remember. I only know how to do differentiation for now. How do you integrate? So integrate against x first. That means you integrate x lah. Okay. So x squared. So we still have the y limits. Don't forget, we have to copy those down. So we integrate x first. So it becomes what? X.
The power of 3.
Yeah,
Over.
right. Yeah. Yeah, very good. Thank you. Yeah. And next, plus. So here we have y squared. Do we have to do anything with the y? How do you integrate?
Add
No?
Well, it doesn't become 0, right? So y, so in this case, y is the constant. Yeah, it's just like differentiation. Now, because you're integrating x, y is constant. So we just copy down y. Okay. When you integrate a constant, does it become 0 or do you get an x?
X.
Yeah. Imagine this. I integrate 8 dx. What does it become? 8x, right? 8x plus c lah. Agree?
Yes.
Yeah. So therefore, for this one, if I only have y squared, then if I integrate y squared, I get y squared x. Okay? And then your limits are 0 and 1. Okay, and then don't forget the dy because we haven't done dy. Okay, so then you just substitute your numbers in. So what easy lah, 1/3 plus y squared. 1 times y squared is still y squared. Okay, 0 masuk 0 becomes 0. Okay, so that's it. There. So now you differentiate. So now you integrate it against y now. Okay. So 1/3 integrate against y, you get y over 3. I think, yeah. And then y squared, you integrate, you get y cubed over 3. And then your limits are this and this. You substitute, -1. Yeah. And then you substitute in, you're gonna get the answer. Okay, you know how to substitute in, right? I don't have to show you. You substitute the numbers in, you get the final answer. Any questions about this?
No, all clear.
Okay, very good. Okay, next.
Sorry, doctor?
Yeah.
Can you just write the final answer? How is it supposed to be like?
Actually, I don't have the final answer.
Okay.
I don't have the final answer.
Okay.
I just simply came up with this question without the answer. Okay, but if you can get up to this point, it should be very easy. It should be fairly easy already. Yeah.
Yes, yes.
Okay. So next example. Okay. So next example. Wait, let me think. Do I want to go through this or that first? Okay, let's go through this one first. All right. So, right. So the next example is very important. All right. So I have another integration here. Okay. And then I give you the regions. Okay. So, okay. So, okay. So again, the step is like that. First, you have to draw the region. Okay. Now, let me explain to you exactly what we are doing here. Okay. So whenever I give you question like that, okay, whenever I give you a question like that, now you can see there are two variables. There are two variables, x and y. That means you have to integrate these two times because there are two variables, but you have to integrate two times. Okay. If there's only one variable, what you did in calculus 1, if there's only x or if it's only y, then you integrate one time. Okay, it would suffice. But in my case, because I have two variables, x and y, that means you have to integrate two times. However, you have to decide whether you integrate x first or you integrate y first, which is why here I put dA. Here I put dA only because you have to decide whether you do dx dy or dy dx. Okay? Dx dy means you want to integrate x first. Dy dx means you integrate y first. Okay? And then x. Okay? And then this r is the limit which you have to find. Okay? It's the limits which you have to find. Okay? You use this to find the limits. Okay? Now, this is not the limit. This is not the limits. This is what you use to find the limits. Okay? So, as always, we have to start by drawing the region. Without drawing the region, you are not going to know what the limits are. Well, some of you may say, some of you may come and say, actually, sir, I know what the limit is. Yeah, because here, x is 0 to half, y is 0 to square root 1 of x. Okay? You may come and say to me, that, well, sir, why don't we make the limit just like that? I integrate x first. So like that. And then I integrate y. Yeah. You may come to me and say that, sir, actually the limit is like this, right? I can just look at the region and I copy it down and I know what limit is. Yeah. This is where the danger is. If you copy this region straight away down here and you do it like that, you'll find that you're not going to get the answer. Okay. If you just copy the limits down like that and you start integrating, you'll find that it's actually wrong. Okay. I will show you why now. I will show you why. This is why you always start by drawing the region. Okay. When you draw the region, it will inform you how to obtain the actual limits. Okay, so let's draw the region. Okay, so when you draw the region, always based on the variables, we have an x variable, we have a y variable. Okay, so for x is 0 to half. Okay, so x is 0 is here, x to half is there. Yeah, so x is half is there. Okay, so we have the first set of region. Okay, so we have the x-axis region, but now, and so now we have to get the y-axis region. Okay, so y equals to, well, y is bigger than 0. Well, okay, sorry. Let me explain a bit deeper about the x one first. Okay, so x, if you look at x is 0. This is x. So this is what the x-axis is. This is how the x-axis is defined. Okay, x is bigger than 0. X is bigger or equals to 0. X is smaller or equals to half. What that means is, you draw x is 0, x equals to half. What that means is x is bigger or equals to 0. X is smaller or equals to half. Smaller or equals to half. Okay, do you get this?
Yes.
Yeah. Okay, so you get this, huh? Okay. So next, y. Y is bigger or equals to 0. So therefore, you find your y equals to 0 line. Bigger, so must be pointing upwards, lah. Okay, it's bigger than 0. So y has to be pointing upwards. Next, y is less than square root 1 minus x. What is square root 1 minus x? Okay, so this is where you need to, well, you can plot this. Just plot this. Y equals to square root 1 minus x. How do you plot this? Well, it's y squared equals to 1 minus x. And then if you rearrange, you get x equals to this. Yeah? Yeah. Okay. What is this curve? Well, you can plot. You can plot. If you don't know, you plot that. You plot. If you cannot guess, then you plot. Okay? You plot x and then you get y. So if you plot x, I don't know, you try with 0, then you're gonna get a number. Then you go half, you're gonna get a number. Then you go 1, you're gonna get a number. Then maybe you try negative half, you get another number. Yeah, if you don't know. Okay, but I can tell you. Okay. So you can try plotting or you can guess the shape. Okay, now we know y equals to x squared is what shape? This, right?
Yes.
Y equals to this guy. Well, no. X equals to y squared is what shape?
C.
Yeah, C. X equals to negative y squared is what shape?
the opposite side of C.
Is that right? Yeah. So that is us. X equals to negative. Yeah. X equals to negative y squared. Okay. So you can either guess the shape, or if you're not sure, you plot. You just plot. You know roughly. If you look at this region, you know roughly what's the x and y coordinate we need. You just use the same x and y coordinate here, you get a shape. Okay, basically, it's this. That's the shape you're gonna get. That's the shape. Okay, that's the shape you're gonna get. Okay, you plot. You can plot to get the shape. Okay, this is. Let me draw it properly. It's actually like that. Yeah, it's actually like that. Okay. So this is y equals to square root 1 minus x. Okay. Okay. So now we have the region. Okay. Wait. Not finish. Okay. So y is less than or equals to square root 1 minus x. Therefore, it has to be less than. So therefore, that means it's pointing down. Less than, ma. Okay. So where is the region? It's everything enclosed by the 4 arrows. There. That is the region. Is this the region? You see where the question mark? Is that a region? No. Why? Because it's more. It's more than your x equals to half. It's outside your x equals to half. It's not the region. Okay? So you have to be, that's why you have to draw the arrow as well. Yeah? You have to draw the arrow so that you know exactly where. If you don't draw the arrow, you may make the mistake and say, oh, actually, this is the region, it's all right. Some of you may do that. You may assume that's the region as well. It's not. Yeah? It's not. Oops. Okay? So everyone know the question mark, the place where I put a question mark. Everyone knows why that is not the region, huh?
Yes.
Yeah, because of the arrow. I already drew this arrow. It has to be inside, not outside. Okay? That's why you have to draw the arrow as well. I forgot to mention. Okay? Okay, so now we have the region. We are going to use this region to do two things. We will use this region to do two things. To decide the order of integration. So when I say order of integration, that means, do I want to do dx dy first or dy dx? Okay, so basically it means, do I want to integrate x first or do I want to integrate y first? Okay, you use this to decide order of integration and use this to get the limits. Okay. Okay, so next we can set up our integration. So step 1, draw the region. Good, correct. Step 2, set up your integration. So the first thing is, you need to decide the order of integration. Then you can find the limits. Okay, how do you decide now? There are two choices. Okay, there are two choices. You can either do dx first or do dy first. Oh, wait, my leg cramp. Wait. Okay, so let me give you an example. Let's say I want to do x first. Okay, let's say I want to do x first. So example, let's say we do dx dy. Okay, let's say we do dx dy. That means we integrate. That means we integrate x first, and we integrate y second. Okay. So the function is 2y. Okay. So we want to do x and y later. Okay. So that means the first limit has to be x. The second limit is y. Okay. So now let's go get our limits. Okay. Okay. So I want to do x first. That means I draw the x line first. Okay. So here, now I'm going to draw my x line. You pay attention what's happening. Okay. So I'm going to draw my dx line, like what I did in the first example. You're gonna notice something very funny. I draw my x line. I draw my dx line. I draw. Go. First point it hits is what? X is what?
0.
Everyone? Yeah. Okay. Okay. I want something else. I want other people to answer me as well. Okay. So I keep going. I hit x equals to 0 first. Then I keep going. And then I hit what line? Someone else? What line is that?
Y line.
Yeah, it's well, you can rearrange this. You hit this line. You hit this line, right? Y equals to this. Well, you can rearrange that. You can rearrange it to get x. You can rearrange to get x. Okay? You can rearrange it to get x. It's actually x equals to what? We did it just now.
1 minus y squared.
It's x. Yeah. So there. That's our limit. 0 and 1 minus y squared. Yeah. So basically this curve is y equals to square root 1 minus x. Okay. But if you're using it for the dx, for the x, if you're using it for the x limits, then obviously you have to convert lah. You have to convert to x. So when it's x, it's actually x equals to 1 minus y squared. Okay. Okay. So far, no problem, right? We got the limits right. Yeah.
Sorry, doctor.
Yeah.
Why did you draw the line from the top? Why didn't you draw it from the lower?
You mean why don't I draw like that? You mean why I don't draw it?
Yeah.
Correct. Very good question. Very good. Very good question. This is where the problem is. If you do dx first. This is what I'm gonna get to later. This is actually the next thing I'm gonna show you. Okay, so very good question, Hussein. Okay, why didn't I draw this first? Actually, you have to consider this as well. Yeah, I just start at the top first, and then only I want to do the bottom one as well. Okay, the problem with dx is if I draw the line at the top, I have limit of 0 and I have a limit of 1 minus x equals to 1 minus y squared. If I draw it at the bottom, I get a limit of x equals to 0. And then I get another limit of x equals to half. I get two different limits for x. Do you notice the problem? Do you guys see this problem?
Yes.
Yes.
No. Because of this, we cannot do x first. It's wrong. Okay. So very good. So yeah, so Hussein noticed the problem already. Okay. So This is why we don't do dx first. Exactly this problem. Okay. So the only option that we have left is we do dy first. Okay, we cannot do dx dy. Okay. So try dy dx. Okay, so we try dy dx. Okay. So you copy this down. I want to clear my region. Yeah. Okay. Okay. So now I'm saying we do dy. Okay, we do dy first. So if we do dy, that means it's dy dx. Okay, that means your first limit is y, your second limit is x. Okay, so let's do y first. So y means vertical lah, y axis. Okay, so let's do y first. I go up, I hit y equals to 0. I keep going up, I hit y equals to square root 1 minus x. Okay, so this is the x line. Now, y no problem. Wherever I draw y, I get the same limits. So no problem. Okay, so now I have my y limits. Since I use red color there, I might as well use red color here. dy. Okay, so next, green color, we do dx. Okay. Okay, now there's one thing I didn't make clear just now. Okay, and it's intentional. Okay, now when you I start with something simple. When you do your when you have a region, okay, let's say a region like that. Okay, that's your region. Okay, when you have a region like that, if you do dy first, whichever you do one first, whichever one you do first, you have to draw the line. Yeah, like what we did. So if I do dy first, then I have to draw the line. I have to get the line. I have to get the points at which it hits. Okay, I have to get the points at which it hits. Okay, so if y here is 1 and here is 2, therefore my limits is y equals to 2, y equals to 1. Okay, you have to get the points at which it hits. Now, for the second limit, dx, okay, dx, actually, strictly speaking, for the second integration limit, you don't have to draw the line. You don't have to draw that line. Okay, what you do is you find the smallest number for the x-axis and you find the biggest number for the x-axis. That's enough. You just get those two numbers, it's enough. Okay, so I'll demonstrate to you what I actually mean. Okay, so Okay, so here, so back to our example, for dy, because we are doing dy first, because we are doing dy first, therefore, that's why for dy, I draw the line up. And I get the two limits by finding what my line hits. My line hits y equals to 0. My red line hits y equals to square root 1 minus x. Okay, so this is how I do dy. Now, for the dx limit, next is the dx limit. Now, for the dx limit, actually, you don't have to draw a line like that. Okay, for the second limit. Okay, for the second limit, what you do is along the x-axis, you get the smallest number, you get the biggest number. Okay, which is 0 and half. Okay, so that is the rule. The first limit, or rather, for the first limit, you need to draw your dy line and get limit. You get your limits based on what the line hits. For the second limit, you just get the limits based on smallest number and largest number along the axis. Okay. Okay, so this is the rule. For the first limit, you have to do it based on your line, what the line hits. For the second limit, you just go with the smallest number and largest number. Okay, this is one rule. This is rule number 1. Yeah. There is actually another rule. This rule is actually more straightforward. You just remember this rule, you'll be okay. Okay, it's when you do the limits. Now, when you do the limits, pay attention. Pay attention. You want to make sure. Let me just write rule number 2. Okay, rule number 2. Rule number 2, you just have to make sure the outer limits. Okay, the second limit. This is the second one, the second integral. Okay, the second limits is always pure number only. No variables. Make sure your second limit is always numbers only. Number, no variables. Yeah. My first limit has variable. It has x in there. Yeah. If you look at my first limit, there's an x in there. My second set of limit is just number. Okay. So this is the second rule you have to obey. Make sure the second set of limits outside, the one you do last, only has numbers. So that, well, I think you can guess why. So that when you get the final answer, it's a number. Yeah. So that when you get the final answer, you get a number. You don't end up with variable. Okay. Do you understand this?
Yes.
Yeah. Always make sure you have numbers or constants outside. Okay. The way you set up your integration. Okay. So there we set up the integration. So you start integrating lah. we can start integrating this. So we start integrating y. So I'm gonna continue by integrating this. Yeah, I'm integrating y first. So when I integrate y, 2xy, integrate y, I get 2xy squared over 2. So 2 cancel out. So I get xy squared, right? And then the limit is this and this. Okay. So then you put your thing in. You put your thing in. You will get so x is constant. So we substitute y in here. We substitute y in here times squared. So this thing squared. Nah, like that. I think. Not sure. So then the square root and the square cancels out. So it's x minus x squared dy. So now we dx because we do dy first. Sorry. X. This is x. Yeah. X because we integrate y first. Okay, so now we integrate against x. Yeah. So if you notice, my first set of limits, it has x in there. That's why the answer, you still have x. Yeah. So now we integrate against x. We get x squared over 2 minus x cubed over 3. And the limit is this and that. You you put everything in there, you should get this answer. Okay, this one I found an answer 1/12. Okay, you do this later on your own. Make sure you can get 1/12. Yeah, for the final answer. Okay, let's go through one more example. Okay, I want to go through another example here, but this example, we are focusing mainly on how, again, on the region, not on the integration part, on the region. Anyone? Okay, let me do this first, and then I ask you whether you have any questions or not. Okay, so let's say I have some example, maybe 2xy as well. Okay, 2xy. Okay, but now the region is different. Okay, so for the region, I'm not going to give you something like what I did just now. This one, descriptive. I can also do it like this. Region bound by y equals to x. Y equals to x. And y equals to x squared. Oh my god. How are you going to get the limits? Okay, so again, don't worry. That's why I say. You always start by drawing the region. Once you draw the region, you will get the answer. Don't worry. Draw the region first. Okay, draw the region. Then you get the answer. All will be revealed once you draw the region. Okay, so draw region. What does this region look like? So again, I noticed this before. I noticed this before when I'm marking exam paper. Okay. Now, when I say draw region, I mean you draw this and that. You draw this so. You don't draw the function. You don't draw that function. It's not that I'm interested. When I say draw region, I mean this and that, not the actual function. Yeah. So, what is y equals to 2x? How do you draw it on an x and y graph? Yeah, so when I say draw region, that means I want you to draw it on an x and y graph. What is y equals to 2x? Well, use table lah. If you're not sure, then draw a table lah. X and y. Then you try x equals to 1. What do you get? X equals to 0. What do you get? X equals to 1. X equals to 2. Then you get your y points. Then you know what you can get. Basically, it's like that. You get a line. So when let's do it together. When x equals to 0, what is y? 0, right? When x equals to 1, what is y? 2 lah. When x equals to 2, what is y? 4. Yeah. So now we can plot 0, 0 and 2, 4. 2, 4. Oops. It's a line like that. Oh, not quite. Doesn't quite hit it. It's a line like that. That is y equals to 2x. Okay, then y equals to x squared. Again, if you don't know, you draw lah. You draw the thing. Yeah. You again use the table method. But basically it's like that. Y equals to x squared it's u ma. It's a U shape. Yeah. That. Okay. Next thing. What is missing from here? Okay, now you have to find your region. Now all we have is two curves. One is the y equals to x squared. The other one is the y equals to 2x. We don't actually have the region yet, the shaded region. Where do you think the region is? Well, it says here, R is the region bounded by this line and that curve. Where is the region that is fully covered by that line and the curve? Well, it's that one, isn't it? This is the only place that is fully bounded by the two. The rest is open-ended. Agree?
Yes.
Yeah, everything else is not bounded by these two. Yeah, only that area there. Okay, so that is your region. Next. Now that you have your region, we integrate. Okay, we integrate again. Dx or dy or dy dx. Now you have to decide. Dx dy or dy dx. Okay, so as I said before, so let's find the limit for both. We don't care whether it works or not. We just find the limit for both. Okay. Okay, fine. Limits. For dx dy and dy dx. Okay, now next before we can actually do anything, okay. Let me start. Okay, so as I said, if you do dx dy, that means for the first limit, x, you have to follow the line method. And then y, you just choose the biggest number and the smallest number. Let's say number lah. Okay. The first limit, you always have to use the line method. The second limit, you can use you choose the biggest number and the smallest number. Okay. So here, we want to do dx first. So that's why dx, we use the line method. So x. So x, we go until we hit the region. So we go there. We hit the first boundary. Yeah, so now that's our region with enclosed boundary. So I drew my dx line horizontally until it hits the first boundary of my region. This is the region. Yeah, the shaded area. Yeah. Okay. What is my x limit there? It's the sloping line, right? Yeah, it's a sloping line. So therefore, what do you think the limit should be? X equals to what? That sloping line. Well, you have to rearrange.
Y over 2.
Yeah, correct. Y over 2. Everyone know why it's y over 2, huh? Everyone else, do you know why it's y over 2?
Yes. Yes.
You rearrange, huh? You just rearrange the function for the equation for that line. Okay. Okay, then I keep going. I hit my second point. What is the x there?
Square root y.
Yep, correct. Square root y. Yeah. Okay. So that's your first limit. Okay, that's the first limit. Next, we do dy. So as I said before, for the second set of limit, you don't have to draw the line anymore. You choose the biggest number and the smallest number in that region. So the smallest number, you can see it's there. The biggest number is there. Yeah, that is the smallest number that defines the region, and the largest number that defines the region. But we don't actually know what it is. We don't actually have the number there. We don't know where that intersect. We don't know where that intersect. Yeah, we don't know the intersect. So we have to find intersection point. How do you find intersection point? The way I draw it, it's close to 2, but it may not be 2. Here, it looks like it might be 0, but you're not sure. We cannot just look at it. Oh, looks like it's 0. Well, that's because I draw it like 0. It may not be 0. Yeah. What is the y here? What is the y value there? What is the y value there? We don't know. There's actually no value. Yeah, we just simply draw. You have to actually find what the intersection point is, How do you find the intersection point? Well, we have this we have this, and we have this, right? These two equations hits each other at these 2 points. So to get intersection point, you just equate the two lah. You just equate 2x equals to x squared. You just equate the two. Yeah, to find intersection point, you equate the two. You know this method, right?
Yes.
To find intersection point, you just equate the two. Okay, then you solve. Okay, so 2x equals to x squared. So we arrange, you get x squared minus 2x equals to 0. Oops, what happened? Line. Okay. Oops, it's lost just now. Okay, let me rewrite again. X squared minus 2x equals to 0. You take the x out. Yeah. So there. So therefore, what is x and y? Well, there are two possible values, right? X equals to 0. There are two possible answers. X equals to
2.
right. X equals to 0, x equals to 2. Therefore, when x equals to 0, what is y? Well, you just put your 0 in there, you get y, you get 0. And then when x equals to 2, what is y? 4, right? 4, right? Agree?
Yes.
Yes.
Okay, yeah. So therefore, the two intersection points are 0, 0 and 2, 4. So what that means is, let me redraw it here so that it's clear. What that means is, our two curves, I can even delete this to make it clearer. There, yeah. So without x and y, without plotting this on x and y, I intentionally delete this x and y. You can still know the two intersection points are 0, 0 and 2, 4. Well, 0, 0 must be there lah, because it's a smaller number, 0, 0. And then 2, 4 must be there. Yeah, this is where it intersects. Okay, 0, 0 and 2, 4. Yeah. Therefore, what are the x limits? So let's go back here. So we know the intersection point here is 0, 0 and 2, 4. This is 2, 4. Okay. So therefore, what is y? What is the smaller y? What is the biggest y? Well, you look here. Sorry, I did it on the x-axis just now, which is wrong. Supposed to be y. What is the smallest y-axis value? What is the biggest y-axis value? Yeah, you look at that region, smallest x and smallest y and biggest y. Smallest y is what? 0 kan?
Yes. 0, 4.
Yeah, 4. Then 2, 4. There, those are your limits. Then you continue integrate. Then you just start integrating. Then finish. Okay. So we've done the dx dy. Now let's do dy dx.
Sorry, doctor.
Yeah.
Why did you write y's value 2?
Oh, 0, 0, 0. Correct. Yeah, you're right. 0. Okay, thank you. Okay. So we've done dx. So we've done dx dy. Next, we do dy dx. Okay, so same. The thing with dy dx also is if we do dy first, therefore now the dy you need to use line method, dx you just use what I call the number method. Okay, the first one is always line method. The second one is always number method. Doesn't matter whether the first one is dy or dx. Okay. Okay. So now because we are doing with dy first, now the dy you need to use the line method. Okay. So dy. So go back here. I have to delete all this. It's very oh no. Ah. Okay, so why? So why you have to do the line method? Okay, so why? Now we are doing y first. So why we have to use line method? So vertically. So y is vertical. So we go vertically up. Y method. We hit something. What do we hit first? Y equals to it's the parabola kan? It's the parabola. Y equals to x squared, right? And if I keep going, what do I hit next? Y equals to
2x.
and you go up. Okay. And this is dy. Okay. Now with this example, you see whether I do dx or dy first, I always have only one set of limits. It's not like the previous example. Yeah. X squared 2x. Okay. Next, for your dx limit, then you just choose the biggest x-axis number and the smallest x-axis number. So x-axis number, the smallest one is there. Biggest number is, well, that one there, that line there. X equals to 2. Yeah, 0 and 2. There. That's your limit. Can everyone understand what happened?
So, doctor, may I ask?
Yep, yes.
Can't we put x's value and y's value instead of the equation in both of the integrations?
You mean for which one? For dx dy or dy dx?
We already got the values for x and y, right?
Correct.
Yeah. So can't we put the values instead of the equation?
No, you cannot.
Okay.
It cannot because why? For the first one you cannot. For this one, and this one you cannot. For the red one you cannot. For the first integration you cannot, because the first integration you have to use the line method. So when you use the line method, let me draw somewhere. Let me draw. Okay, I draw here. Okay. Let's say I want to do. Let's say now I want to do dx dy. You're asking why I cannot use why for the x limit you cannot use number. Is that what you're asking?
Yes.
Yeah, because the first integration you always have to use the line method. So when you use the line method, you draw a line. You have to find what that line hits. The line is not hitting the limit. The line is hitting a point somewhere here. We don't know what that number is. We don't know what that coordinate is. Do you agree?
Okay, yeah, I get it.
You know the coordinate. You only know it hits that curve and it hits that curve, but there's no coordinate there. There are no coordinates there. You don't know what those coordinates are. That's why you need to use the equation. Yeah.
Okay. Yes, I get it.
Yeah, it's only for the second one. This one you use the second one. You always you can just use the number, smallest number and biggest number. Okay.
Okay, thank you, doctor.
Okay, no problem. Okay, so now it's kind of easy. Ooh, this one's a bit crazy. Let me take a look. Okay, let's do this one. This one is very simple. Okay, this one is not simple, but similar to what we did. That's why I want to choose it. we do the harder stuff on Friday. Okay. Right now I want to go through the basics with you, so we do something simpler. Okay. Okay, so I give you this question. Before you decide whether you want to do dx first or dy first, or you start integrating, the first step is always draw the region first. No matter what happens, draw the region first. Then only you decide what you want to do later. Okay, always start with draw the region first. How do you draw this region? Well, it's again that curve and this curve, right? Yeah. So plotting this and that, you should know how to do it, because in calculus 2, I'm not actually teaching you how to draw these two things. You should know from calculus 1 and before this. Okay. If you don't know how to draw, you have to learn how to draw these two lines. Okay, you have to go back and revise and learn how to draw these two lines. Okay, basically, I will draw it for you now, but you have to learn how to draw yourself. Learn how to draw yourself. Okay, basically, y equals to x minus 1, where y equals to x minus 1 is actually y equals to x squared lah. It's something like that. Okay. So you again use your table. You just use your table. You should get something like this. You should get something like this. Parabola. It's a parabola. Yeah, it's a parabola. It's a parabola. It's a parabola. So difficult to draw. It's a parabola that is not at 0, 0. Okay, it's a parabola that's not at 0, 0. Okay. You need to learn how to draw this, otherwise you will struggle with drawing the region. Okay. The first one is that. The second one, very simple. Y equals to minus x plus 3. So y is equals to x. Well, y equals to x plus 3 is what? This one very simple. Whatever y value you have the same x value. Yeah, whatever y value you put in, you should have the same value. So it should be y equals to x. It should be a 45-degree line. Agree?
Yes.
Y equals to negative x is what? 45-degree the other way lah. Agree?
Yes.
Good. What about the plus 3? The plus 3 is y-intercept, right? So therefore, this is negative x, so it's going the other way. The plus 3 is the y-intercept there lah. That's the plus 3. So where do you think is the region bound? If I extend this a little bit, where do you think is the region bound? That one, right? Agree?
Yes.
Good. Okay, so 1x. Okay, so again, later on, every time you get this question, you get this type of question, you will know what's going to happen. When you find your smallest number and your biggest number, you need to know the coordinates there. You need to know the coordinates there. Basically, you need to know that intersection point. You need to know this intersection point. Yeah, I mark in red. You need to know this intersection point. You need to know that intersection point to get your smallest number and biggest number, regardless of whether it's x or y axis. So the first thing you have to do always, what? Find intersection point. Yeah. How do you find intersection point? Yeah. You know y is negative x plus 3. You know y is this. So you just equate the two. So negative x plus 3 equals to x. So expand this. So x squared minus x minus 2 equals to 0. So x minus 2, x minus 1 equals to 0. Therefore, x equals to 2, x equals to 1 or negative 1. One of them has to be negative. Yeah. Therefore, what are your intersection points? 2, 1, negative 1, 4. Okay, you work this out yourself. You try to find the intersection points yourself. I'm giving you the answer now. It's these 2 points. Okay, you learn how to do this yourself. So basically 2, 1 and 1, 4. So this must be 2, 1. That must be negative 1, 4 up there. Yep. So now you have your intersection points. next. So, well, you have your intersection points and you have your region. So now we set up integration. Yeah. Okay. So let's say I want to do dy dx. Let's say I want to do dy dx. What is my y limits? Y limits is what? You give me the answer. Someone else, Hussein has helped me a lot, so now I want someone else to help me. I will wait here until you give me the answer. What is the y? What are the y limits? Someone else besides Hussein.
X minus 1 square and minus X plus 3.
Okay, very good. Thank you. Siapa tu?
Ryan.
So the x minus 1 squared is at the bottom, right? Because that's the one you hit first. Is that correct?
Yes.
Okay, good. Thank you. Okay, and then the x limits is what? The biggest number and smallest number along the x-axis. Smallest number is what? Negative?
Negative 1.
Yeah, the smallest number there, -1. And then you just look at the coordinates. The x-axis value, smallest is -1, biggest is 2. Okay. And then do you guys know how to integrate this, or do I have to integrate for you? This one very easy to integrate, right? The final answer, if you do this, final answer is this. Okay. Okay, next. What if I want to do x first? What would be my x-axis limits? Okay, so just now we did y first. Okay, so we went this way. Now we want to do dx first. So when we do dx, okay, this is where you see the problem. So if I want to do dx first, I go here. I have one set of limits. I go through the bottom. Here, I have another set of limits. Correct? Yeah, because if I go through the top, I hit the parabola and then I hit the straight line. If I go through the bottom, I hit the parabola and then I hit the parabola again. Do you see the problem? Hit parabola again. At the top, I hit parabola and then I hit straight line. So what does that mean? You cannot do this. This doesn't work. Okay?
Okay.
Yeah. Everyone understand why I cannot do dx first?
Yes.
Okay, very good. Okay, so for this example, make sure you can get the so go with dy dx. Make sure you can get 72/5. That's the final answer. Finish up the integration. Make sure you get 72/5 for the final answer. What else? Okay, I think that's it. We can end the class here. I will see you on Friday. Friday we should be able to finish up this topic.
Okay, doctor.
So-
Thank you.
So what I want you to do after this, I want you to revise all of this. Make sure you understand what I talked about. Okay?
Okay.
Right. Okay, thank you. Oh, wait. The attendance. Wait for the attendance. Okay, I've shared with you the attendance link. Make sure you do it by 10 o'clock. It will expire in 13 minutes. Make sure you do it by 10 o'clock. All right, I'll see you on Friday.
Thank you,
Okay.
doctor.
Thank you, doctor.
Okay, doctor.
Thank you, doctor.
Thank you, doctor.